Recording. It says I'm recording. I hope this is visible. I see that's my leg of my tripod. Let me see if I can straighten this out a little better. Okay. Slide down here a little more. Okay. This is an Atlantic. This is as original as they get. Okay. This has been restored, disassembled, cleaned, and repaired with original parts. Looking for a pointer of some kind so I can point. All I have is a stick. This is the headlight. This is the smoke. The smoke comes out of here. This is the smoke housing. In here is a piston, and it pushes the smoke out. This is the smoke gear motor, and it runs on a worm gear off of the what we call open frame. You know, there's a difference between a DC can. This is a DC can. We call them cans because they look like a can. All of these motors have a gear. See if I can get my hands on one right away and show you how they're put together and what. Okay, here we go. This is the AC motor as AC Gilbert put them together. It has armature and fields. All right. The armature would fit into the fields like this. It would be held together within the frame of the engine. And there's a little cap that helps align that. If I can find one. Quick. No. Maybe. I really prepared for this, yeah? No luck. No luck. There's one. There's one. Hold on. See if I can get it fast enough. I don't want anything attached. Okay, good. We're golden. This is a very old brush holder device. It holds the brushes that run on the armature, but it also provides the end bearing cap for this. So the bushing fits into that little piece of shaft, and the fields fit into those notches. And now this then would fit into the engine frame, just like the frame I just found for you. There's a surface there. Let me get it. Here's the frame that I found. And here would be a vintage American Flyer motor, open frame, AC power. So AC would come in here, and AC would power the fields, and when you energize it, that motor would spin. Okay? Now when that motor spins, oh, you dog, here we go. It rotates here. It rotates this piece, and that worm drives this gear right here. That's what spins it. Got it? That's what's going on. So this would go in here. This would come here. Energy would tell it to spin, and it would rotate the gears. That's how this is assembled. That's how it works. The key parameters in the motor part, I get this apart without killing myself. The key parameter is this surface, a 10-degree angle on that gear, and the diameter of that gear. That tells you the positioning of this axle shaft and this surface and that motor center point. Okay, those are all calculations I have. They can be made. They're not hard, and you can design parts to them because I already have. Okay, so let me show you the reverse. So the wiring is 2 wires to the field, 2 wires to the brushes, and they go back to here, and this is a reverse unit. This is a mechanical drum that ratchets back and forth It's a simple mechanism. See the drum, and it has little surfaces and and then they switch. The little tabs go from one side to the other, and there's fingers on top of this. You can see the fingers right there, and that's what takes the energy back, and that's what switches right and left. The side pieces never change, the center pieces do, and the harnesses change that way. So I'm going to turn this on. You'll hear a click and a buzz. That's a solenoid. This has a ratchet inside here. You can see this ratchet effect. See how it changes as I do that, and that's a solenoid. So it's AC powered. It can run DC too. It's just a solenoid. So I ratchet it again, and now it's connected. The circuit's complete, and the energy is running into both fields and brushes, and the motor's turning. You see the motor turning, and I can smell it, but maybe you can see it. There is smoke coming out of that little chute right there. See it? I don't know if you can. I don't have anything for contrast. There is a little bit of smoke coming out. I'm going very slow. I'm only at 10 volts. Okay? Now, I can speed up. You hear the chuff sound? That's a mechanical whistle, more or less. Then the piston makes the chuff and pushes the smoke out at the same time. It's really an interesting approach. We don't mind it. It's mechanical, but we don't mind it. Neutral is when you lift up on the throttle, you shut the throttle off, there's zero voltage going through, everything goes to neutral. When I ratchet it again, it clicks. Now it's in neutral. Now, when I do it again, it's going to be in the opposite direction. Now it's going forwards. Before it was going in reverse. So this is how we change directions. We stop power, neutral, reverse, neutral, forward. And rotating the throttle up and down, that's 15 volts. 15 volts in our day is flat out, okay? They can handle more, but nothing over 20. 17 tops, okay? And you can throttle it, slow it down. You can see there's a little smoke coming out. I don't know why the light bulb's not lit. It should be, but maybe it's unscrewed. Sometimes, yeah, there it is. I unscrew that sometimes just to save some of the amps, to get the heater hotter. Okay, so this is what we call conventional, original, post-war, 1947 up through 66, up to the very end. They never varied from the AC power and the open frame motor. Now then, for a variation of some magnitude, first of all, you'll see this has 6 wheels. Alright, so this has 6 wheels instead of 2. It does not have that smoke. This is the smoke I designed. This is 3D smoke, 3D printed smoke. It has a DC motor, tiny mini DC motor running a fan, sucks air in here, blows it out here, and the motor you see is now a can motor. When I showed you the can motor before, I just showed it like this. There is an adapter plate that matches to the mating surface, and then it screws to the motor, and that adapts the motor, but it also has a shaft that adapts the shaft to the gear. So the DC can motors we get are in America through one major supplier, and he does the adaptation and he makes the metal interface. In this case, this had the smoke gear. There are some engines that do not have a smoke gear. Here's one that did not have the smoke gear, so it can't run the conventional smoke. So I put an adapter plate and I put this smoke on here, but I don't have a trigger used to puff the smoke out on this engine. There is a way to do it with a cam using the smoke gear if you have the smoke gear, but if you don't have the smoke gear, like a lot of the old engines, here's another one where this is the reverse unit, but there's no smoke. There's no room for smoke. There's no place to put a cam. There's no place to put an extra gear or anything. So I came up with this device, which is a spacer and an adapter. It has an extra shaft for an extra gear. That extra gear replaces this gear here, this smoke gear. What's happened is I've pushed the motor back just enough that I can put an extra gear on the shaft. I've backed it up and I can put an extra gear right there. So I have made my own gear that meshes with this. It's a big fat worm gear that fits in here, and then this gear sits on top and it rotates off. So what you're going to see is this turns as the wheel turns, and I'm feeding a pulse through these two limit switches. One pulse goes to this motor to create the smoke puff. The other switch goes back to a soundboard, which creates the digital chuff sound. Chuff, 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 chuff. And they're synchronized because they're running off the same gear. On the sides of the teeth are little bumps, 4 bumps per rev. 1 rev matches the rev of the wheel. This is my digital approach to getting chassis that don't have a smoke gear smoke. And these chassis, like yours, right? No gear, no room, no smoke. $15. They're very cheap. And look, I have all the axles and even the side railings. So we need to change. We need to make a change. Sorry about that. In the chassis to adapt the 3D printed smoke and the 3D printed extra gearing to have a smoke gear. But guess what? It works. It works real well. This is for an engine that never had smoke, never had chuff, never had sound. This engine is called the Royal Blue, and it's a streamlined steam engine. Notice it has a slot. That was for the reverse unit in here, so it never had room for smoke. Well, I've replaced digital electronics, the smoke, added the gear. So this is all, there's a plate on top here that's 3D printed that holds all these parts. The one thing this is an older unit, maybe it's about 1.5 years old. The one thing I would change today, I can't find one right away, but I would change my volt regulator to a buck boost, and I'll show you why. If I go below 8 volts, my sound system can't operate. So at low speed, which I can go low speed, see that? I can go low speed, but I can't generate the sound or the smoke at low speed. If I put a buck boost board in here, I would have the correct voltage for everything at low speed, medium, and high speed. So I need to update this unit with the buck boost board. Okay. Right now, this controller I'm using vintage Lionel controller, $25 for digital. It runs a DC, it takes AC and outputs DC voltage to DC motors. The challenge I have with it is its size. It's pretty big. It takes a lot of space. This soundboard is an older single board unit. It's limited sounds, but it's okay. It's adequate. It's fun. Nice big speaker. These two can work well together, but they're not coordinated. There's no wireless control with this engine. It's all from the transformer and all track voltage, which is variable from 5 to 15 volts typically. But with the buck boost board update here, this thing would run real well, low speed and high speed. Okay. Now that buck boost, I'd have to have two. One for the no, this is just the smoke. That's right, because these run on DC anyway. Okay. Now I'm going to move ahead a little bit. All right, you've seen enough of that, I guess. So 3D printed frame here. 3D printed adapter, a pair of 3D printed gears, a 3D printed adapter, a 3D printed smoke, and a 3D printed heater holder element. Okay, so I'm going to take this. Well, I can just hold this up right now. Now this is old school, right? Piston, turning the crank, turning the smoke, but one of the differences is no fields. No fields. Where are the fields? There aren't any. Why not? How do you get away with that? Well, there's what I call super magnets in here. I use magnetics to replace the fields, and I convert this open frame AC into an open frame DC. So this is now a DC motor. So now I can run it. I can run AC to the track, go through the buck boost, through any controller I want, and run the motor, and then another controller for the smoke heater so it doesn't burn out. And this one had the gear, so it's easy to put the old smoke back in. Okay, now then, what else can I show you? Here is that's a 6-axle, that's for a Pacific. That would be for something like this, nice big Pacific. This is for the Atlantic, which is a much smaller engine. It's for 4 wheels and shorter and lighter. But you can see this sits in here like that, that sits in here like that, and that's how it would look. This is another 3D printed part. I call them fireboxes, and I put flicker fire in there, LED stuff. The reason I did that was it hides the motor. You don't see the electric motor when you put it in there. So that's a rundown of the big pieces, where I've taken it and what I've done. And I made this in steps. I want to let you know. I did take an original Flyer smoke, 3D print an adapter to put a fan motor in here. I added a piece of tubing, and I'm actually blowing air into the heat chamber and pulling fresh air down the sides, creating a turbine. So I've adapted these things, and you can do it. My problem was I'm cutting up classic equipment that cannot be replaced, and I felt bad about doing it. So that's when I decided to build my own, the entire housing in 3D print. Okay, so from steam engine point of view, this is the engine part, the smoke and the motor explained in more detail. It's not touching on the tender wheels and all-wheel pickup. That's late, that's just current, so you've seen that already. But this, with just the chassis and a body, which you can get, not expensive, all the other bits and pieces can be printed and installed, oops, and run on this. This is vintage flyer track, which we can get for $1 a piece, and sometimes less, by the basket, by the box. Then you need the transformer. Okay, I have other videos on the Rail Pro to show you those components and how they work. You can see those and put it all together in your head and think it over, see what it is. But there's a lot we can do with the least desirable chassis, which is a nice casting, very heavy, a lot of meat. We could take them apart, clean them, put them back together, and they run like new. Update the motor. You can go with a can, or you can take the existing motor and convert it. I have converted, hold on. Thought I did. Yeah. Well, I can't find it fast enough, but believe me, I have converted these fields. I've taken these wired fields, unwound them, cut slots in it, and put permanent magnet motors inside them. Cut the windings out and put permanent magnet motors inside these fields so they look like that. I have created DC motors from AC motors, so we can even do that. And these AC motors are not expensive because they're old and open frame. This is plastic, and this all fits with the existing interface. The motors that we get, the DC can motors that we get, come with that adapter plate. So that's all you have to worry about, is that angle and that pitch and the run-in for the thread. You can get the worm gear separately. I think they're not cheap. I think they're $10 a piece. The motors are like $30, $35 a piece, complete with the adapter and the worm gear. So it's a mixed bag how far you want to go. One thing I want to point out is you can see this motor is shorter than that motor, so there are some variations in the motor. It's usually length, and the smaller the engine, the less motor it can handle. The larger engines can take larger motors. That's basically how that works. Oh, and from the smoke, here's the little smoke piece. This is a Lionel propeller. These motors you can get on Amazon. This plate I print out to match that smoke body housing. Here we go. Here's the smoke housing. So this just bolts on like that. It has a hole in the center that is open to this vent here, so it pulls air in from the sides, and it creates a turbine effect, and it pushes it to the outside, so that upper hole is connected into the smoke chamber. In here would be angel hair or rock wool, and hanging from these two holes on top would be the heater. That's how the smoke operates. And then the adapter, I showed you. Thought I had one. Here's an adapter for another engine. I think this is for a Atlantic over there. But the adapter has holes in it to mount the smoke in the right location. And then this screws down to the chassis. This one clips on the front and then has one screw in the back. It doesn't move. So this is how you would assemble this smoke versus the old smoke. You see? The original flyer versus 3D printed. I make this adapter part because I knew I was going to have different engines. They were going to have different mountings, where Flyer is able to make them all go with this. They have some engines that don't have smoke, and there's no way to mount their smoke. Like this one. This is a good chassis, but there's no way to put this on. It just doesn't work. And there's no gear to drive the piston in and out. So you have to adapt it with digital control and motors. But it works. I've been building and sending these out, usually on custom models and some of my own, for a couple of years. Alright, I guess that's it in a nutshell. I'm sure I'll have questions, which is fine. I might end this with a peek at something else. This is a diesel engine. This is a American Flyer Alco diesel. It's a beautiful engine. Everybody loves the Alcos. This is the chassis for it. I've been working on adding all-wheel pickup to it so it has more electrical reliability. As you can see, this one has the typical reverse and the open frame motor. I'm also converting these motors to DC as well, and look what we have. That is a diesel smokehouse. The same method here. So the diesel, while it doesn't puff, it does have smoke from the diesel exhaust, and we emulate that out the top with that smoke adapter. I'll be finishing that as soon as I'm done with this other engine. And then again, the buck boost helps us with low speed smoke because it can boost it at low speed and low amp. Take the low volts using amps, built it up. So I'm enthusiastic with all of these pieces. Alright, I'm going to close, try to send this up, and we can talk.